Okay, you notice in part A that the position vector turned out to have positive x component and positive y component, and this means that our particle is located in the first quadrant at t equal 4 seconds. The time 4 seconds, my object is having a positive x component, positive y component, so it is in the first quadrant. Let us move to part B. Find the velocity at time t equal 4 seconds. We know the position. We want to find what is the velocity. Okay, so the velocity, he is asking us about v final. Okay, so v final at t equal 4 seconds, where that was v initial when the time was 0 at the beginning, and now he's asking about v final. V final, we know it has two components. It has x component, so v final x in the I direction plus v final y in the j direction. So we'd like to calculate what is the x component of the final velocity and what is the y component of the final velocity. So I have to treat the x component separately from the y component as we have done in the previous part. Okay, so v final x is unknown, but I know v initial x, which was 3 meters per second. I know the acceleration in the x direction, which is minus 1 meter per second square, and the time is given. Okay, so the time is 4 seconds. You notice that I have 1, 2, 3, 3 known quantities, and the fourth quantity is unknown. So which equation should I use here? I should use the equation which doesn't have displacement. So this will be equation number 1. So use equation number 1. So here v final x equals v initial x plus axt. Everything I have here except v final x. So v initial x was 3, then minus 1 multiplied by 4, and I am left with v final x equals minus 1 meter per second. So the x component of the velocity is negative, and it has magnitude of 1. Now we'll do the same for v final in the y direction. So v final y is unknown. Would like to find it. V initial y is given. V initial y is 4 meter per second. The y component of the acceleration is given, which is minus 0.4 meter per second square, and the time, as we know, is common for both components x and y. It is 4 seconds. 1, 2, 3 known quantities and 1 unknown, and we'll use similarly equation number 1. So v final y, v final in the y direction equals v initial y plus ayt. This is unknown. V initial y was 4 minus 0.4 multiplied by 4. So this is 4 minus 1.6, and this is 2.4 meter per second, and this is positive quantity. So v final y is positive, and it is 2.4 meter per second. So the final velocity has two components, so I can give my answer here, plug it in this formula. So v final is nothing but minus 1 in the I direction plus 2.4 in the j direction, and the units, always don't forget to put the correct units. So this is the answer for part B. He's asking about velocity, and the velocity is a vector, so I should give it to him in vector notation. Okay, next part, He's asking about the speed. Find the speed at time t equal 4. We know the velocity. The velocity was minus 1I plus 2.4 j. The speed at that moment will be the magnitude of the velocity. Okay? So the speed is a scalar quantity, and it is the magnitude of the velocity at that time. So speed equals the magnitude of v final. From our study in chapter number 3, related to vectors, the magnitude of any vector is the square root of its x component squared plus its y component squared. So I am left with square root of the x component squared. So I have minus 1 squared plus 2.4 squared, and this is equal to 2.6 meter per second, and this is the speed of my particle at t equals 4 seconds. By the way, the speed is always positive, okay, because it is the absolute value or the magnitude of the velocity vector. Okay, because in mathematics you have studied that the square root can have positive and negative, but we will choose only the positive quantity. Part D of this comprehensive example, find the average velocity between time t equals 0 at the beginning of the motion and t equals 4 seconds. Okay? Let us use the definition of average velocity. We defined the average velocity, V average, I'm talking about average velocity. So this is nothing but delta R, the displacement, by delta t. What is the displacement? Displacement is R final, okay, minus R initial divided by delta t, which is t final minus t initial. Okay? But what was the position vector at the beginning of the motion? He said the particle was at the origin initially. So R initial is 0. It has x component of 0, y component of 0. So R initial is equal to 0. So I am left with R final divided by delta t. So what is R final? We found this at the beginning in part A. R final, it is there, 4I plus 12.8 j. So V average will be R final divided by delta t, but R final is 4I plus 12.8 j divided by 4. If we divide, we'll get V average. The average velocity will be 1 in the I direction plus 3.2 in the j direction. This is the average velocity, and the units are meter per second. So this is the answer for part D. Let us take one further step for this comprehensive example. What is the maximum x coordinate reached by the particle? Okay, let me explain this question first. You notice something here, that my object initially has a positive velocity. Its velocity is having positive x component, and it has positive y component. But the acceleration has negative x component and negative y component. So what will happen to this positive velocity? We learned before that if the velocity and the acceleration are in opposite direction, what will happen to my object? It will decelerate. Okay, so we have positive 3. Let us talk about the x-axis. It has 3 positive component in the I direction, but the acceleration in the x direction is negative. So this will decrease with time. So this quantity or this x component will decrease with time because I have opposite sign for the acceleration and the velocity. Similarly for the y component. So my object was moving in the positive x direction, but decelerating, it means it will reach the maximum x coordinate when its x component of the velocity will be equal to 0. Then it will change direction, okay? So this is very important to notice. Maximum x coordinate will be achieved, this implies that v final x should be equal to 0. In other examples or other questions, he might ask you, what is the maximum y coordinate reached by the particle? In that case, you have to put v final in the y direction should be equal to 0. This is very important rule you have to recognize. Okay, so maximum x coordinate at that point, v final x will be 0. He's asking me about x final at that point. So x final would like to know. Okay, x initial we know it was 0. X initial was 0. V final x is 0. V initial x we know it is given 3 meter per second, and we know the x component of the acceleration, which is minus 1 meter per second square. Okay, so I have 1, 2, 3 known physical quantities, and the fourth quantity, which is delta x, is unknown for us. So which equation should I use here? I need the equation which doesn't have time. Okay, which equation of motion that doesn't have time is equation number 3. So we have to use equation number 3. What does it say, equation number 3? It says v final x square minus v initial x square equals 2ax delta x. Okay, v final x is 0, it is given here. Okay, so I have minus v initial x is 3 squared equals minus 2 multiplied by 1, because I have acceleration is minus 1, multiplied by delta x. Okay, so I am left with the following. Delta x will be 3 squared, which is 9 divided by 2, and this will be 4.5 meters. But delta x is nothing but v x final minus x initial equals 4.5 meters, and this x initial was 0, so I am left with x final equals 4.5 meter, and this will be the maximum x coordinate. Why is it the maximum x coordinate? Because at that point Vx is equal to 0. So after this, what will happen to the x component of the velocity? It will be negative. Okay, and you notice here at time t equal 4 seconds, at a later time than this one. Okay, we notice that Vx is a negative value. Okay, so here the time is less than 4 seconds. We can find the time. At what time this will happen? Okay, so let us increase one more. E, A, B, C, D, E, F. At what time does or is the particle at maximum x coordinate? Oh, this is a very good question. So my question now is very comprehensive. It covers many ideas. So let us answer this.